So last but not least, we have Venus. And Venus, as I said, from what I've found out or read about on the internet, we believe it's geologically active. One of the problems we have with Venus is we can't really use a telescope and see through Venus's thick clouds to the surface of Venus. But you're going to see some surface shots of Venus, and generally these were taken by, it was mapped, the surface of Venus was mapped using kind of like a radar, by sending down signal and looking for that signal to bounce back. So remember that Venus is kind of Earth's sister planet with regard to size, and that's one of the reasons we think it's geologically active. But this is looking at a surface feature on Venus. Again, we kind of have to take this through its dense clouds using some sort of radar. But Venus does not seem to have all the craters that little Mercury and Moon has. Okay. And it also looks like Venus has its fair share of these kind of, I believe they're dormant, but volcanoes. Venus also looks like it's kind of broken up into maybe plates, kind of fractured like that. This actually is a spacecraft. Can you kind of see this little, you can see that little bit of the spacecraft on the planet Venus. Now, I think it's kind of funny because as much as we have put spacecraft, or I should say rovers, on the planet Mars, in this, I want to say the 70s, the planet Venus was visited by the Soviet Union. So if you take a look at my playlist of YouTube videos, I do have a video there with photographs of the surface of Venus. So Venus is definitely a terrestrial planet, and you can kind of see it. It just looks different, doesn't it? That's kind of cool. So we believe that Venus is geologically active, but planet scientists, some of them anyway, believe that it doesn't like have plate tectonics that move on the mantle like the Earth does. Instead, the heat, the internal heat, kind of builds up and builds up and builds up, and so that every 750 million years or so, basically that heat has built up so much that it basically liquefies the crust, and then it resolidifies. So kind of all at once, it turns into this blob, and then it gets smooth again. I think that is so bizarre. So Venus is very hot, and the daytime side of Venus is about the same temperature as the nighttime side of Venus, and that's about 470 degrees Celsius. That's very, very hot. Okay. And I think I've already mentioned why Venus is so hot. It has a thick atmosphere, and a large component in its atmosphere is that carbon dioxide that traps Venus's heat. So how thick is Venus's atmosphere? Oh, let me go back. How thick is it? So here on Earth, if you're walking around, okay, you have, at the Earth's surface is basically the thickest of Earth's atmosphere. And we have about 13 pounds per square inch is the pressure that our atmosphere is exerting on us. Okay, well, if you were walking around on the surface of Venus, you would have, instead of 13 pounds per square inch, take that times 90. So you'd basically have an excess of 900 pounds per square inch. That's kind of the pressure you would have if you're walking around on the surface of Venus. So the reason there's so much pressure, or I don't know which came first, the chicken or the egg, but it's a very thick atmosphere, mostly, like I said, of carbon dioxide. And the carbon dioxide then is excellent for trapping thermal energy that the planet wants to maybe it wants that thermal energy to escape into outer space. So, and like this slide says here, that not only is Earth's atmosphere thinner than Venus, but also features on the Earth's atmosphere, specifically its oceans, its large bodies of water, and even its its rocks have kind of absorbed some of the carbon dioxide that might have otherwise been greenhouse gases here on Earth. So I mentioned that we really can't see the surface of Venus with just regular telescopes. So the Venus is covered in clouds, but those clouds aren't clouds of water droplets. Those are clouds that are actually sulfuric acid, liquid sulfuric acid droplets. So some would kind of point to Venus and be concerned that what's happening at Venus on the planet Venus could actually happen here. So if we consider Earth and kind of a similar situation as Venus, we could relocate Earth to where Venus is, and we would have more evaporation because we'd be closer to the sun. And one of the things then is that as that water evaporated and went to the Earth's atmosphere, actually water is a greenhouse gas. So then with more water vapor in the Earth's atmosphere, we'd have more warming, okay? And so with more warming, we could have more evaporation. With more evaporation, we have more greenhouse gases. We have more warming. So this is called kind of what we say a positive feedback mechanism, where something's going on to kind of ramp up, in this case, the greenhouse effect. So this would be kind of the runaway greenhouse effect that we want to avoid. Now, the Earth is not going to relocate, obviously, to the orbit of Venus, but we can also have kind of this runaway greenhouse effect if we simply do things related to man's activity to increase our surface temperatures.